Section 10-5 is actually not all that difficult, but it is in general, but it is a very amazing section because of what you're allowed to do. It's called natural logarithms, and so obviously these are things that are found in nature, and it might be very hard to kind of read that first part right there. But what this basically says is log base e of x equals natural log of x. Now I know it's funny that it's an L and then an N. You can blame the French for that because they called it log naturel. But natural log is basically a log base e. Now e is actually a number that occurs a lot in nature. And just to give you an idea of what e is, I'll bring up the calculator here in a little bit and let it run. But E is a number they found in leaves and clouds, and it's just all over the place in exponential growth and decay. And it's a number that's 2.71828, and it keeps going on. It's kind of like pi in a sense that it keeps just going on and on and on. And here it comes. And so to find what E is very simply, here's your natural log on the left side over here. Like kind of if you take the 7 and the 4 and go just to the left of that, there's the natural log. And right above it is E to the x, at least on these calculators. And so if I just basically take E, see right there, to the first power, it'll tell me what E is. So 2.718281828. And it doesn't repeat like that. It just becomes gibberish after that. But it's something that they found in all over the place. It's just, it truly is amazing how much you can do with it. And so what we're going to do is just get a very general start with it. And we're going to find, well, what is the natural log of, say, 3.12, and then what is the anti-natural log of 0.2594, so forth and so on. And so whenever you see natural log, you can think of that as log base E. So what this one's really saying is log base E of 3.12 would equal some x value. So we are really, what you're trying to do is E to what power would give me 3.12. Now we could sit there all day and try and figure that out. But if E is 2.718, so forth and so on, we know this is going to be just a little bit more than 1. But obviously we don't want to sit there and guess all day, and so we are just going to let the calculator do that. I would have you make educated guesses, but it's really hard with that horrible decimal to know, well, what happens if you take it to the 3rd and 4th power. It gets really kind of iffy as how you're going to do that. And so this one here is the natural log of 3.12. So very easily, all you have to do is hit natural log 3.12. Close it off, and it would tell you we're expecting something around 1. Oh, so that makes sense. Now, had we got something around 2, I would hope you would say, wait a minute, that can't possibly be right. And so that one makes sense. And so why don't you take a second right now on whichever calculator you have, or if you need to go get a calculator, go do that, and find the natural log of the next two, which are what, 0.045 and 0.772. Why don't you go ahead and find those answers? All right, hopefully that was enough time to go get a calculator and kind of start typing that out. Well, if I take 2.7, again, kind of try and figure out what it's actually asking you. So it's log base E of 0.045 would well, that's a x, not a 5. 5 would equal some x value. So it's really saying E to what power would give me 0.045. Well, 2.7, again, that's what E is, to the 0 power would give me 1, and 0.045 is less than 1, so we would expect some kind of, or less than 0, excuse me, we'd expect some kind of negative number here, would be a very logical answer, and I believe it's negative 3.1011 is a normal place that you would round that one, and the first one we would probably round to 1.1378 or something like that. Isn't that what it said? We go 1.13, yeah, 78 is what we would have for that first one. And this one again is saying E to what power would give me that. Because remember, these are logarithms, so it's saying find the exponent that would give me that if EE was our base. And once again, this is less than that, and so we'd expect a negative. And this one is negative 0.2 0.588-ish, something like that. Okay. And so again, those aren't overly difficult. If I had to make an educated guess, they would be a lot more complicated, but that's not what we're doing here. So if a logarithm, again, is asking you for the exponent, an anti-log would be doing the opposite, and the opposite of asking for an exponent is giving an exponent. And so it's basically saying that e to that power is what? Is really what it's asking. And the nice thing with the calculator is it has anti-log on there, and basically it should be no surprise that with natural logs right there, anti-log is right above it. It's e to some power. And this one is e to 0.2594. And we do that. And again, we're saying 2 to some power, 2.78 to some power. That's less than 1, so it makes sense that we're less than 2.7. Right? And so we get 1.2962. I guess you would round that to if we rounded out that far. Okay, so it would be 1.2962. Once again, I want to take a second or two and find those. Again, we're saying e to that power. So this one's saying about 2.7 to the second power. So we should be able to get pretty close to where that would be. We would expect it probably to be less than 9 and probably more than 4 somewhere, because I just took 2 squared and 3 squared. And anti-natural log there of a negative. Well, so we got e to some negative power, so we're going to expect something very small there, because we're doing 1 over e to that power. Okay. Let's go ahead and do that. All right, I'm expecting that was probably enough time. Now, if you're not getting these numbers, probably ask a neighbor or make sure that you're typing in the right thing. So I got 7.5195, something like that, and 0.2066 is what I got for those. And so those are very believable. Okay. So now those are pretty straightforward problems. Now let's just look at a type of problem that would use E. And one of them is if you compound interest continuously is what it's called. Another way, obviously, is exponential growth and decay, and we'll talk about that one later. But A equals PE to the RT is what you see right here. A is the amount of money that was in the account after T years, so the amount in the end. P is the principal, or the amount you started with. E is just E, it's that number, 2.718. R is the rate, but make sure you make a little note of the rate there. It's the rate written as a decimal. Yeah, there it is, decimal. And then T is, of course, time. So I would like to go to Australia in 2 years. That would be nice. I need to save $8,000 for the trip. I found a 2-year certificate of deposit. That's something that you can get at a bank. And I was getting 5% basically interest compounded continuously on that. Then how much money would I have to invest to have enough money to go to Australia? So first we got to figure out, well, what do we know, what do we don't know? Well, of the A equals PE to RT, we know E. It's 2.71828, blah, blah, blah. Our calculator is going to store that information for us. But what other things do we know? For example, do we know A? Do we know the amount that I need basically when all is said and done? Yes, I do. It's 8,000. So A is 8,000. So basically we got that. Equals, got that. P, do we know how much to start with, the principal? Well, no, that's the one thing we don't know, right? So we'll put a P there. Again, E is E, so no big surprise there. R is the rate, and so you have to write it as a decimal though, remember. So it's 0.05. And then T is time, and so 2 years. So of this math right now, I'm just going to extend that down a bit, we can take this 0.05 times the 2, so we've got 8,000 equals P, and we've got E to 0.05 times 2, which is, of course, 0.1. And our calculator can find out what e to the 0.1 is. It can do that for us. Okay, it wouldn't have a problem doing that. Now, a lot of you are going to say, oh, let's use a natural log, let's do something like that. We want to cancel out that e. Well, we don't have to do that because we want to get p by itself. And so what we can do is let the calculator do this for us. We can simply, in this particular problem, divide by e to the 0.1. Right? Cancels right there. And so we're going to take 8,000 and divide by e to the 0.1. Now, you got to be a little careful when you type that in to make sure nothing weird happens. And let's go ahead and let's try that and see what we come up with. No, we don't need that. And so we got 8,000 divided by, and I would probably put parentheses on that if I were you, like this. There we go. And e, remember, is anti-natural log, really. And then 0.1, close off that parenthesis, would close off the 0.1, and then we do another one to close off the bottom e part. And we get 7,238, and then of course here we're going to round a little bit differently because this is money. So we'll say $7,238.70 is what we would round to. Now we could have done that in a much more complicated way, but for today I think that's enough. So 7,238.70. So with that in mind, I know that I am not going to Australia in 2 years because I do not have $7,238.70 to put into the bank right now. So really over 2 years you didn't get a lot, but that's not bad. You're not going to find a CD for 5% return for only $7,000. So if you find that one, let me know. I'll still invest, but I'm not going to be going to Australia. I can guarantee that. Now that takes care of the notes, but on the back of the notes you might want to take a look at, maybe coming up with a one of them that's going to be on your worksheet. What I'm going to want you to do is make an educated guess. The directions also say to find it with a scientific calculator. I'm not going to show you how to do that until you get back. And so what I want you to do is just kind of make an educated guess. For example, if I were to give you log base, it doesn't even really matter. We'll say 3 of, and then you just kind of give me some kind of number, maybe 30 or something like that. And I want you to make an educated guess as to what that would be. Now remember that you could say equals some x, so you're looking for 3 to what power would give me 30. What you got to think about is, well, we know that 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. Okay, so we're getting pretty close. So we know it's got this little answer for x right here. We know it's going to be bigger than 3. And then 3 to the fourth is 81. And so we would guess somewhere between, it's kind of one of those between again, it'd be between 3 and 4 somewhere, but definitely much closer to 3. Okay? And so I want you to make an educated guess on that, and then I will show you how to do it on a scientific calculator eventually, and that'll give you the actual answer. But again, I want you to know what you're solving for before I show you how to do that on a calculator. Okay. And that's it.